It begins with a question so simple, yet so daring. How big is the Earth? For centuries, civilizations gazed at the horizon and watched the stars, but no one could say for sure. The Earth was vast, the tools were primitive, and the dangers of exploration were very real. In ancient Greece, one man dared to try. Around the 3rd century BC, Eratosthenes compared the shadows cast in 2 distant Egyptian cities. Using only mathematics, he calculated the Earth's circumference with astonishing precision, over 40,000 kilometers. But this knowledge did not spread easily. Wars, the rise and fall of empires, libraries burned. For much of history, the true size of our planet was forgotten, ignored, or distorted by myth. By the age of exploration, in the 15th and 16th centuries, sailors like Magellan and Columbus gambled on the shape and size of Earth. For some, the gamble meant glory. For many others, ruin. As global trade expanded, maps became weapons of power, but they were riddled with errors. Continents were drawn misshapen, distances were guesses, even the tilt of the Earth's axis remained a profound mystery. By the 17th century, scientists turned to the heavens. Isaac Newton proposed that Earth was not a perfect sphere, it was bulged at the equator. Others strongly disagreed. The only way to settle the dispute was to measure. And so the stage was set for one of the boldest projects in scientific history. Teams of explorers, astronomers, and adventurers would risk their lives to answer Newton's question, what is the true shape of Earth? 2 great expeditions were planned, one to the icy north, the other to the wild mountains of South America. Each journey would test not only science, but the endurance of the human spirit. The chaos of measuring the Earth would not be tidy. It would be marked by hunger, disease, betrayal, and storms. Yet through the chaos, science would inch forward. In the year 1735, a group of French scientists set sail for South America. Ahead of them lay jungles, volcanoes, and a mystery that had haunted humankind for millennia. 2 grand expeditions set out to resolve Newton's great debate. One team went north to the Arctic, the other south to the high Andes Mountains. Their singular goal, to measure a single degree of latitude and finally decide the true shape of Earth. The South American expedition faced danger from the first step. The Andes were not gentle hills, but colossal mountains that scraped the sky. The air was thin, the terrain unforgiving, and the journey felt immediately cursed. Storms shredded their camps. Hunger and tropical disease thinned their ranks. Local rebellions flared up, and the fragile trust between the French scientists began to fracture. Some whispered this was a mission doomed by fate. Still, they measured endlessly. Triangles, baselines, and calculations were repeated again and again. For years, they compared the stars overhead with lines stretched across vast, impossible valleys. The work was agonizingly slow, the cost in human terms enormous. Meanwhile, in the icy north, the Lapland expedition moved with rapid speed. Despite freezing winds and the endless darkness of winter, their measurements were completed in a single year. Their results pointed directly to Newton's theory. The Earth was indeed flattened at the poles. Back in South America, the Andes team was trapped in endless delays and internal conflict. Months turned to years. A mission meant to last a few seasons stretched to nearly a decade. Friendships had curdled into bitter rivalries. The mountains demanded sacrifice. One scientist fell to his death from a dizzying cliff. Another succumbed to tropical fever, and in a cruel twist of fate, their painstakingly gathered data sometimes contradicted itself. Precision had come at the enormous cost of lives. Finally, after nearly 10 years, their mission ended. Their results conclusively confirmed what Newton had predicted. Earth bulges at the equator. The Andes had not been easily conquered. They had consumed men, but the truth of the planet had at last emerged. But the expedition left deep scars. Friendships never recovered. Some men returned to France bankrupt, others mentally broken. La Condamine himself stayed behind in South America for years, perhaps unable or simply unwilling to go home. The Andes expedition became a legend, a tale of genius and profound suffering, triumph and ruin. Yet it was only the beginning. For as Newton's ideas took hold, new questions arose, and the rivalry among scientists would soon turn bitter and desperate. If you want to follow this chaotic journey through genius, betrayal, and obsession, stay with us. And if you're new here, join our voyage. There's much more ahead. London, late 17th century. Coffee houses buzz with arguments. Science is no longer hidden in monasteries. It thrives in raw debate, furious challenge, and fierce ego. At the epicenter of this intellectual storm stood 3 men: Halley, Hooke, and Newton. Edmund Halley, the master navigator of the stars, asked a question that burned in every serious mind. What immense force binds the planets in their perfect, predictable orbits? Robert Hooke, a brilliant yet intensely combative thinker, claimed he had the answer: gravity, pulling everything toward a central point. But his compelling ideas lacked the rigorous precision of pure mathematics. Halley turned to Isaac Newton, a man famously withdrawn from the world, living in near isolation. When asked, Newton revealed he had already solved the problem years earlier, then simply hidden the crucial papers in a drawer. When Newton's manuscript emerged, it astonished Halley. In precise, elegant lines of mathematics, Newton proved that the same universal force pulling an apple to Earth also perfectly guided the moon in its immense orbit. But Hooke would not yield. He furiously accused Newton of stealing his ideas, claiming the core concept of gravity was his discovery alone. The quarrel turned vicious and bitter. Soon, the Royal Society itself became a battlefield of intellectual pride. Halley played the crucial role of peacemaker, urging and encouraging Newton to finally publish his work. Without Halley's unwavering support, both financial and emotional, Newton's masterpiece, the Principia Mathematica, might never have seen the light of day. Published in the year 1687, the Principia forever reshaped human thought. The heavens and the earth were no longer separate mystical realms. They obeyed the same single universal laws. Yet for Newton, victory only deepened his profound solitude. He distrusted rivals, feared public betrayal, and began to aggressively close himself off. What the world saw as monumental triumph, Newton carried as a suffocating burden. The law of universal gravity had been born, but its genius father was a man haunted by deep darkness. In the next chapter, we descend into Newton's private world. To the world, Isaac Newton was the man who had flawlessly explained the cosmos, but behind closed doors he was fiercely secretive, profoundly fragile, and consumed by inner obsessions that had little to do with observable science. Born in 1642, during a great storm in rural England, Newton came into the world so small and frail that no one thought he would live. Survival shaped him. He grew up convinced he was chosen for a unique and destined greatness. As a student, Newton was quiet and withdrawn, but his notebooks burned with strange private experiments. He famously stared at the sun until his vision blurred. He even slid needles between his own eye and bone, driven only by the terrifying urge to see how light truly worked. When the Great Plague swept through Cambridge in 1665, Newton retreated to the countryside. Alone, in isolation, he simultaneously developed the world-changing ideas of calculus, optics, and universal gravity. But Newton was no serene philosopher. He was notoriously paranoid, quick to lethal rage, and utterly ruthless toward rivals. He feuded bitterly with Robert Hooke, and years later, in an ultimate act of spite, he had Hooke's only known portrait erased from the Royal Society. Even in power, Newton remained a cold isolationist. As the powerful master of the mint, he hunted counterfeiters with merciless zeal, using the full force of the law to send many of his targets to the gallows. He poured decades into alchemy, searching for hidden secret metals and divine esoteric truths. To his enlightened peers, this pursuit seemed like pure madness. To Newton, it was a terrifyingly higher, spiritual calling. Newton's genius was unmatched, but so was his profound loneliness. He never married, never formed close, lasting friendships. His world-changing brilliance came at the ultimate cost of human connection. And yet, through his obsessions and internal battles, Newton gave humanity a new, unified universe, one governed not by the fickle whims of gods or myth, but by eternal logical laws that could be measured and tested. But Newton's vision was not the final word. Across the Channel in Paris, a brilliant established dynasty of astronomers named Cassini prepared to challenge him. The very shape of the Earth would become their international battlefield. In Paris, the Cassini family reigned supreme over astronomy. For generations, they had charted the stars with unmatched, meticulous precision. But in the early 18th century, their professional focus shifted to the very shape of the Earth itself. The Cassinis believed the Earth was stretched at the poles, an elongated prolate spheroid. Newton, across the English Channel, vehemently declared the opposite, that it was bulged at the equator. This dispute was no quiet academic quarrel. It rapidly swelled into a matter of overwhelming national pride. France and England, old geopolitical rivals, now stood on fiercely opposite sides of scientific truth, science becoming an extension of empire. To prove their French case, the Cassinis planned two bold, distant expeditions. One would brave the icy cold of Lapland, near the Arctic Circle. The other would face the fierce, unforgiving mountains of Peru. In 1736, the Lapland mission began. Teams hauled heavy telescopes through relentless snow and endless darkness, battling punishing frostbite and gnawing hunger to get their readings. Meanwhile, in South America, the second French team carved a painful path through dense jungles and high volcanoes. Finally, the precise measurements from both ends of the Earth arrived, and the truth was unavoidable. Newton had been right. The planet demonstrably bulged at the equator. The dynastic pride of the Cassinis was defeated, but the Cassinis would not surrender easily. They furiously accused their rivals of errors, even outright fraud, attempting to discredit the results. What had begun as pure science now dangerously resembled a bitter personal war. In the end, France gracefully accepted Newton's universal truth. Yet the Cassinis' fall marked a turning point. The age of dynastic, isolated astronomers was giving way to a new kind of science, collaborative, international, and utterly brutal in its demands for empirical truth. But the battle for Earth's shape was not the final frontier. Across the vast ocean, two intrepid Englishmen, Mason and Dixon, would soon use the stars to draw a line that would forever split a continent in two. In 1750, two Englishmen set out on a mission that would become legendary: Charles Mason and Jeremiah Dixon. Tasked with measuring a line across the American colonies, they would rely on the heavens themselves to guide their way. Mason and Dixon were more than just surveyors. They were master astronomers, mathematicians, and gritty adventurers. Their critical task, to settle a bitter, decade-long border dispute between Pennsylvania and Maryland with a scientific precision previously unseen in the New World. The American terrain was brutal and unforgiving. Dense, endless forests, steep ridges, and swollen rivers relentlessly blocked their path. Yet, armed with sextants, precise chronometers, and sheer human determination, they pressed onward. At night, the vast clear sky became their indispensable map. Using key stars, Mason and Dixon calculated latitude and longitude with astonishing accuracy. Every reading brought them one step closer to the elusive final boundary line. Their work was meticulous, almost ritualistic in its repetition. Days blurred into weeks, weeks into exhausting months. Each painstaking measurement was a small, intense battle. Conflict was never far from their camp. Tensions with local, suspicious settlers, arguments with rival surveyors, and even encounters with wild animals severely tested their resolve. Yet, Mason and Dixon's professional partnership proved to be remarkably unbreakable. By 1752, after years of painstaking work, the line was finally drawn. Known today simply as the Mason-Dixon line, it became more than just a boundary. It stood as a powerful symbol of scientific precision, human discipline, and sheer endurance. Yet their entire journey was not merely about land. It was a profound testament to human curiosity. Through deep forests, across wild rivers, and under intense storms, they proved that the stars could guide men on Earth with unprecedented, absolute accuracy. The Mason-Dixon line would later gain fame in ways neither man could possibly imagine, dividing states, dividing peoples, and forever splitting history itself. Their tools and their scientific discipline left a towering legacy that outlasted kingdoms. But while Mason and Dixon mapped the stars and the land, back in England, a new, massive experiment awaited, one that would literally attempt to weigh the Earth itself. And here, dear viewer, if you want to witness the final culmination of centuries of scientific obsession, subscribe now and join the journey. In 1774, Britain's royal astronomer, Neville Maskelyne, faced a colossal challenge to accurately measure the mass of the Earth. The answer lay hidden in a majestic Scottish mountain called Halley, whose almost perfect conical shape promised a natural laboratory. Maskelyne's method was audacious, drawing on Newton's law. By measuring the tiny deflection of a plumb line caused by the mountain's visible gravity, he could indirectly estimate the Earth's density. Every calculation required immense patience, surgical precision, and nerves of steel. The Scottish Highlands were utterly unforgiving. Cold winds bit cruelly through thick woolen coats, sudden storms rolled in without warning, and the rugged, uneven terrain severely tested the team's endurance. Yet, Maskelyne pressed on, driven by pure curiosity and immense ambition. Maskelyne was meticulous to the point of obsession. He triangulated, measured precise angles, and rechecked every single observation multiple times. Every tiny swing of the plumb line, every note in the journal, brought him closer to unveiling a secret hidden in the mountain stone for millennia. The final calculations were grueling. Maskelyne, armed only with trigonometry, geometry, and unwavering patience, slowly translated the mountain's subtle gravitational deflection into the numbers that would represent the Earth's density. Each digit carried the weight of centuries of human inquiry. By 1763, Maskelyne had done it. He published the definitive results, revealing that the Earth's average density was nearly 5 times that of water, a groundbreaking revelation that would successfully guide all future experiments for decades. Maskelyne's triumph inspired an entire new generation of scientists. The Halley experiment became a global benchmark, profoundly proving that the Earth could be measured, precisely weighed, and rationally understood, if one only dared to look closely enough. But the true, ultimate climax of human obsession with measuring the Earth was yet to come. In a quiet laboratory in London, a solitary man would soon attempt what no one had ever done, to weigh the Earth itself, directly and precisely. This was Henry Cavendish, a reclusive, eccentric genius whose experiment brilliantly combined physics, chemistry, and pure audacity in a way the world had never witnessed. Yet, the world would barely notice him until the results spoke louder than fame. And so, the final stage was set. Centuries of geographical obsession, perilous journeys, and meticulous calculations were about to culminate in a single, astonishing act, measuring the precise mass of our entire planet. Stick around and discover the mind-bending experiment that changed science forever. In the year 1797, Henry Cavendish, a reclusive English scientist, began one of the most extraordinary experiments in human history. While the world debated, explored, and theorized, Cavendish aimed to measure the mass of the Earth itself. Cavendish's instrument was deceptively simple: a torsion balance, 2 small lead spheres hanging from a thin wire, and 2 much larger spheres positioned nearby to exert gravitational pull. But the required precision was unprecedented. He was attempting to measure a force so incredibly tiny, it was almost imperceptible. Weeks turned into silent months. Cavendish worked in total isolation, recording every tiny deflection, every fraction of a degree. Outside, London bustled with merchants, carriages, and gossip. But inside, time slowed to the precise, agonizing rhythm of science. His results, when finally calculated, were astonishing. By measuring the minute gravitational attraction between the lead spheres, Cavendish could precisely calculate the Earth's density, and from there, its total mass. For the very first time in human history, a man had accurately weighed the entire planet. Cavendish discovered that the Earth had an average density of 5.5 times that of water, a revelation that conclusively confirmed Newton's theory and provided the foundation for modern physics. Yet Cavendish remained largely unnoticed in his own lifetime, a ghostly genius quietly changing the fabric of science. The experiment was exquisitely delicate, almost absurdly so. Any slight vibration, any misstep could immediately destroy weeks of meticulous work. Cavendish labored in complete isolation, yet his mind raced with ambition, aware that the fate of the world's true physical identity hung in the balance of his instruments. Through Cavendish's hands, centuries of human scientific obsession, from the Greeks, the explorers, Newton, and Maskelyne, finally converged in one room. The ultimate dream of accurately measuring the Earth was no longer a philosophical fantasy. It had become measured, tangible reality. But the man behind the monumental discovery remained a profound enigma. Cavendish vanished further from public view, a lifelong recluse who perfectly measured the world but utterly shunned fame. His essential work would shape generations of scientists, yet he lived and died in stark solitude. Cavendish's experiment was the perfect final culmination of human obsession, perilous risk, and soaring intellect. From shadows in ancient Egypt to icy mountains and Scottish peaks, humanity had pursued the seemingly impossible, and finally, scientifically succeeded. The Earth had been weighed, the mysteries of its fundamental mass revealed. And yet, the core story of human curiosity endures, urging each of us to always look up, measure, explore, and dream. And so, dear listener, that's where today's story ends. Let's continue walking the path of great minds and moments together. Remember, every great mind was once just curious. Stay curious, and I'll see you in the next chapter of Mind Mint. Goodbye.